Hello. In today's class we are going to see macroprocessor algorithm. So in the previous class, just a recap of previous class, what we have seen, that is the macro definition. Wherever the macro call is there, then we are going to replace that macro call with the set of instructions which are up there in the macro definition. So macro actually it means that the set of instructions which are there in the definition, we are going to put that in the macro call. Wherever the macro is called, then you are going to place those set of instructions which are there in the definition of the macro. So we have seen in the previous class that read buffer is a read buffer f1 buffer length, that is line number 90. So this we are going to, for this is a macro call, and we are going to substitute the set of instructions which are there in this macro definition, that clear x starting from 190a to 190m. These set of instructions we are going to put it in the macro call, and that call, the macro call, should be commented. That's what we have seen in the past. Similarly, another example we have taken, a write buffer, wherein we are going to substitute the set of instructions whatever is there for that write buffer, we are going to put in that call, right? And similarly, we are going to have another write buff call, wherein you are going to place those set of instructions in the macro call write buff. So this is what we have seen in the previous class, and we also seen that in the line number 220 write buff 050 EOF and 3, these are the actual parameters, or you can say these are the parameters in the call, and wherever it is appearing, now we are going to store this information in this def tab. Read buff is stored here, and it has 3 parameters: indev, buffer address, and record length. So these are preceded with ampersand. As we have seen, these parameters are preceded in the ampersand in the definition. Now we have to see that wherever these parameters are used, these parameters are the positional arguments. So let us consider the first argument is indev, second argument is buffer address, third argument is record length. So these are the 3 arguments which are there for this read buffer. Now where it is called where it is used, that is test device. You can see the statement test device. In test device equals to question mark, and the first argument is used from the parameter. So you're going to replace the port that is the indev by question mark 1. That question mark 1 means it is the first argument in the definition of the macro. Similarly, the second argument, that is parameter, is buffer address, where it is used in the statement stch question mark 2. That means it is referring to the second parameter in the definition. Similarly, stx statement, wherein the third parameter is it is referring the third parameter in the definition of the macro called read buffer. Okay, so this is how you are going to put the information into the defined table. So defined table consists of positional arguments. Those positional arguments are called positional parameter. Those positional arguments are the parameters, and these are prefixed with the ampersand symbol, and wherever these parameters are referred, those positions are referred by in the instruction which are written in the definition of the macro. So in this case, we have seen there are 3 statements which are referring to this positional argument, td, then stch, and third one is stx. So these are referring to the arguments. These are replaced with the positional arguments. So that is the second table, def tab. And the third table is argument table. Argument table, which consists of the actual parameters in the macro call or macro invocation. So f1 is the first argument, second argument is buffer, and third argument is length. So these are corresponding to the macro invocation or macro call. So this is about the recap of whatever we have class. Now we are going to see the data. We have already seen the data structure. Now we are going to see the algorithm, the macroprocessor algorithm. So we are going to have certain procedures we are going to write here. So the first is the processing procedure. Second one is define. Third one is procedure expand, and next one is get line, and another one is a Boolean expression which is either set to true or false. So one by one these procedures we are going to see in this. So let us consider this program. The first part of your program is the main program. So it starts with the main, that is begin, and ends with end. So begin of the macroprocessor, and we are going to write the set of instructions in between begin and end. Now in this macroprocessor algorithm, first we are going to have expanding is assigned to false. That means we have started, and initially we are going to put a value false into expanding. That means initially we are going to process line by line, each line in the source program, and we are going to write in the expanded code. And right now we are not we have just started, so we are going to say expanding is equal to false. So that is the first statement which tells that we have not started the expansion of the macro call. So that's why we are going to have expanding is equal to false. Then we have a while loop here. So what is the while loop? Whenever you take one statement from the source program, first you have to check for the opcode field. If the opcode field is not equal to end, that means you are not, and we are not at the end of the program. So opcode field, until this opcode field is not equal to end, we are going to do the processing. What is that processing we are going to do? We are going to get one line from the source program, and then we are going to process that line. So this is the process until we encounter end opcode in the source program. So this is about the main program. Now let us go to this next procedure, that is process line. Process line. Now we already seen that if opcode is not equal to end, then we are going to call a get line, and this get, when you call this get line, one complete line from the source program you have accessed. Now in that complete line we are going to see the opcode part of that. Now the opcode is, when it is not end, then that opcode first you have to search in the name table. Okay, so we are going to search that opcode in the name table. That means we are first searching whether that opcode is a name of the macro or not. If it is found that it is the name of the macro, then you are going to expand that, whatever is the set of instructions are there in that macro, we are going to replace that in the macro call. So that is called expand. So if you find that the opcode is present in the name tab, then we are going to call a function expand. Else, if opcode is equal to macro, that means we have encountered a definition of the macro. So if you have encountered a opcode which is equal to macro, then we have to define that. That means this information from that definition of the macro till you encounter that end, that you are going to do, that's those set of instructions you are going to put it in the table called def tab, and define table does this. So we are going to call define when we are going to find opcode is equal to macro. Now else if, what we are going to see, it is neither we have not found that in the name tab, we have not found a macro opcode, then it is not a macro or macro call, macro definition or macro call, then obviously it will be a source line which should be placed in the expanded code. So this is the process is done in the process line. In the process line, we are going to see the opcode part, and if this opcode part is present in the name table, then we are going to expand that macro call by the set of instructions which are available in the definition table. If it is not a if the opcode is not equal to name tab, if opcode is not, if it is opcode is equal to macro, then you have encountered a macro call, and we have to define that macro. We have to define that macro in the definition table. And third one is, if it is neither a macro or if it is not a name of the macro, then we are going to write that source line into the expanded. Next procedure is define procedure. So define procedure defines the set of instructions. That means when you find that the macro the opcode is equal to name of the macro, then you are going to enter that macro into the name table. Okay, so if you encounter macro opcode in the opcode part, if you find the macro, then you are going to put that macro in the name tab. So you are going to store the name of the macro in the name tab, and then we are going to enter that macro prototype into the def tab. So that means we are going to store the set of instructions which are there in the definition of the macro. Those set of instructions we are going to store it in the define table. And then the next statement is level 1. Level 1 equals to 1. Now this level, now it is initialized to 1, and we are going to check whether while level is greater than 0, then we are going to enter into this loop. Now again, now first we have got one line, and next we are going to take the next line. So next line is, if it is a next line will be the first line in that definition of the macro. So the next line we are going to take, and then we are going to check whether it is a comment. If it is a comment line, then we are not going to store it in the expanded code. Then we are not going to store that in the define table. So if it is not a comment line, then we are going to substitute the positional notations for the parameters. So wherever the statements which are referring to the parameters, those are replaced with the question mark followed by the position of that parameter. That's what we have seen in the previous example. Then you have to enter that line into the define table. And then if opcode is equal to macro, again you may have a macro defined in a macro. If you have a macro defined in a macro, then you are going to increment the level, that is level equals to level plus 1. If it is not having another macro defined in a macro, then you need not have to do anything. Okay, then you are not going to increment this level. So if you have the macro defined within a macro, then you should increment this level by 1. Now if opcode is not a macro, then you are going to see whether it is a mend, whether the opcode is equal to mend. If opcode is equal to mend, then we are going to decrement the level, because the corresponding for that macro we have got the corresponding mend, and thereby we are going to decrement this level equals to level minus 1. Now this process is continued until the level will become 0. Okay, so in this define table, we are going to store the name of the macro in the name tab, and it is going to store the starting address of that macro definition as well as end address of that macro definition in the name tab. So 3 entries are made in the name tab, that is the name of the macro followed by the starting address of the macro definition and the ending address of that macro definition. And second thing what it is going to do is it is going to store the macro definition in a table called define table, and all the parameters are replaced by the positional arguments. So that is done in the define. So this is about the macro processor algorithm, and we have seen macro is a assembly directive wherein the value of level is incremented by 1, and whenever it encounters amend, the value of level is decremented by 1. Thank you.